Now let us solve few examples based on direction cosines. If a line makes 90 degrees, 135 degrees and 45 degrees with coordinate axis, then find its direction cosines. Now here we are given the angles which a line makes with the axis, so therefore these values are nothing but the values of alpha, beta and gamma, as we can see, and direction cosines are nothing but the cosines of those angles, so therefore L is cos 90 degrees, which is 0, then M will be cos of 135 degrees, which is minus 1 upon root 2, and N is cos of 45 degrees, which is plus 1 upon root 2. So hence the direction cosines are 0, minus 1 by root 2 and 1 by root 2. That's the answer. Let's see the next question. Find direction cosines of a line equally inclined with the coordinate axis. So now here if we imagine some line which is such that the three angles that it makes with the three axes, they all are same. So that means instead of assuming them as alpha, beta and gamma separately, we can consider all the angles to be same as say alpha, correct? And we know that cos square alpha plus cos square beta plus cos square gamma, which is nothing but L square plus M square plus N square, which is equal to 1. But since beta and gamma both are same as alpha, so therefore if we take all as alpha, we will get nothing but 3 cos square alpha equal to 1, which gives us cos alpha is equal to 1 by root 3. Okay? And of course by taking the root we have to consider plus or minus, because that merely indicates the opposite side of the line. So if this is the original direction of a line, then the minus will just indicates the opposite direction on that line. So therefore alpha is nothing but cos inverse of 1 upon root 3 if you consider the acute angle, that is taking the positive value in the cos. So this is the angle which the line makes with all the axes. Let's see the next question. Now here it's given that if a line makes angles alpha, beta and gamma with coordinate axis, then show that sin square alpha plus sin square beta plus sin square gamma equal to 2 and cos 2 alpha plus cos 2 beta plus cos 2 gamma equal to minus 1. Now we know the basic relation, that is cos square alpha plus cos square beta plus cos square gamma is equal to 1. So we make use of that fact. So to prove the first question, let us start off with LHS, where we can write the first term sin square alpha as 1 minus cos square alpha. And similarly we can write the remaining two terms also, that is 1 minus cos square beta and 1 minus cos square gamma. So therefore collecting all the like terms, we collect 1, 1 and 1, that gives us 3, and minus, in the bracket we will have the terms cos square alpha plus cos square beta plus cos square gamma, and we know that this is equal to 1. So therefore on substituting that value we get 3 minus 1, and that turns out to be 2, which is the right hand side. Now in order to prove the second sub question, we observe that we are given the terms in terms of double angles, so cos of double angles. That means we have to somehow write the double angle formula to convert angle 2 alpha into alpha. So here also let us start off with LHS, and we know the double angle formula for cos, that is 2 cos square alpha minus 1. Okay, that's the double angle formula for cos 2 alpha. Similarly we can write, in case of cos 2 beta, we can write 2 cos square beta minus 1 and for cos 2 gamma we can write 2 cos square gamma minus 1. So once again collecting all the like terms, if we observe 2 cos square alpha, 2 cos square beta and 2 cos square gamma, when the cos square terms are added we will get the answer as 1. Hence we have 2 into bracket 1 minus, when you collect the 3 minus 1 terms they give us minus 3, and hence we get 2 into 1, that is 2 minus 3, that is equal to minus 1. That is the right answer. That proves the required result.